How can metallography observe microscopic crack initiation? Imagine trying to find tiny cracks in a metal before they cause a big failure. Metallography is the science that helps us do just that by looking at metals under microscopes. It all starts with preparing a sample of the metal. The sample is polished smooth and then etched with a special chemical that reveals the internal features. This process exposes grain boundaries, tiny pores, inclusions, and dislocation structures that are often the starting points for cracks. Once the sample is ready, scientists use optical microscopes to examine the surface at high magnifications. But for even more detail, they turn to advanced tools like scanning electron microscopes. These microscopes use a focused beam of electrons to produce highly detailed images of the metal's surface and internal features. They can see features as small as a few nanometers, which is essential for spotting early signs of crack formation. Another powerful technique is electron backscatter diffraction. This method maps the crystallographic orientations of the grains in the metal. It helps scientists understand how cracks might start and grow relative to the grain boundaries and phases within the metal. For example, cracks often begin at pores or inclusions where stress concentrates. Metallography can identify these stress concentrators by measuring their size and position. Larger pores or clusters of small pores are more likely to be the initial crack sites because they cause localized stress that pushes the material toward failure. Metallography can also reveal surface features like extrusions or intrusions at the atomic or nanoscale level. These features are often caused by dislocation movements, defects in the crystal structure, that lead to strain. When strain localizes, tiny cracks can form. Using scanning electron microscopy, investigators can observe these early damage signs as they develop, even before visible cracks appear. In failure analysis, metallography helps connect the dots between microstructural defects and the actual failure. By understanding where cracks begin, engineers can improve manufacturing processes. For instance, reducing porosity through techniques like hot isostatic pressing makes the metal less prone to crack initiation. This approach boosts fatigue resistance and extends the life of the component. In summary, metallography observes microscopic crack initiation by preparing a metal sample and examining it under powerful microscopes. These tools reveal tiny defects and early damage features that lead to cracks. Techniques like scanning electron microscopy and electron backscatter diffraction give detailed images and crystallographic maps, showing exactly how and where cracks start. This detailed look helps us understand failure mechanisms and improve material performance.